Hello everyone, welcome to our YouTube channel. I am SUBRAMANIUM from Group ED2U.
Hello, my name is Muhammad AMIN. I'm from ED2U.
Okay, today we're gonna present to you about a type of MOSFET. So here, MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. It's also known as Insulated Gate Field Effect Transistor (IGFET), which consists of a thin layer of silicon oxide between both the gate and the channel. And MOSFET can be further classified as either depletion type or enhancement type of MOSFET. So in this video, we'll learn about the depletion type of MOSFET. There are two types of depletion type of MOSFET, which are N-type and P-type. So first of all, let us see its configuration. Based on the N-type, the channel is made up of N-type material and the substrate is P-type material. And through the metallic contacts, the drain and the source terminals are connected to this N channel, and similarly, the gate terminal is also connected through the metallic contact, but there's no direct connection between this N channel, and this gate terminal is isolated from the channel using SiO2 layer, which is insulating layer. This conducting channel, which is made up of semiconductor material. In case of a P-type depletion type of MOSFET, the channel is made up of P-type semiconductor material and the substrate is N-type. And for the P-channel MOSFET, the polarity of the applied voltage will also get reversed. That is why these MOSFETs are based in the application where the minimum power consumption is required. And this is the basic connection of MOSFET to the power supply. Alright, so now let's see the working of this depletion type of MOSFET. So initially, let us assume that the gate and the source terminals are connected together, and together they are connected to the ground terminal. That means initially let us assume that this VGS is equal to 0 watt, and the positive voltage is applied between the drain and the source terminal. So as soon as we apply the positive voltage, then the electrons in the this N channel will get attracted towards this positive terminal. So if you observe from the source terminal, the electrons start moving towards the drain terminal, and this way the current will establish in this N channel, and this process will continue until all the electrons in this channel will contribute in the flow of current. Next, we are going to learn about characteristic of depletion type of MOSFET. The drain of a DMOSFET N channel should be biased and more positive than the source, so that current IP flows from D to S. The gate terminal is applied with the negative bias voltage to form a depletion region. Negative voltage at the gate will push the free electrons, which is a majority carrier, into the N channel and pull the holes from substrate P material. Recombination will occur and cause the number of free electrons at the N channel decreases. Thus, the conductivity of channel reduced and channel resistance will be increased. Consequently, the flow of IP decreased. As the voltage at the gate becomes more negative, which equals to VGS smaller than 0, the number of free electrons in the N channel will reduce, and the same goes to value of IP. This condition is clearly shown in a certain voltage level, VGS off. Free electrons in channel will be fully depleted and no current flows in IP. DMOSFET gets its name from the depletion of current carrier in this channel. About future trend of the device development and application. In past few years, more and more researchers have been devoted to investigating innovative MOSFETs having more than one gate to enhance the control of ultra-small MOSFET. However, in my opinion, it may require many changes and innovation. The most likely changes are to increase the mobility and improve performance silicon will be mixed with a semiconductor like germanium to produce a strained monocycline silicon layer at the wafer surface that let electrons move faster. Next one is to reduce gate leakage. Gate oxide will be made of materials with higher dielectric constant than today's silicon dioxide. To raise the gate, and next is to reduce the gate resistance and improve channel control, gates will be made of metals instead of polysilicon. That's all from me, and subscribe us to watch more videos based on electronics.